question in this video is, what is acceleration? Our definition, you want to write this part in your notes where it says definition. Definition is that acceleration is the time rate of change in velocity. Another way of saying this is it is how fast the velocity changes direction. And it's very important to note that it is the velocity and not the speed that we are talking about. There are three types of acceleration. And if you look on your notes, you'll see a box where it asks about the three types of acceleration. Those three types are to speed up, slow down, or change direction. So again, the speeding up is something you'd probably be familiar with. And when you speed up, you feel this push backwards in your seat. Whenever you feel a push or a pull, it is because you are accelerating. So as you speed up, you are accelerating because you feel like you're being pushed backwards. You also feel another type of push when you slow down. As you slow down, you feel like something is pushing you forward. Now, some people might call this a deceleration, but in physics, we make no distinction. Whether you are speeding up or slowing down, you are accelerating because you feel this push or a pull. The last way that you can accelerate or feel a push or pull is when you change directions. As you go around a turn, you feel a push from side to side. And because you feel that push side to side, you are accelerating. And therefore, changing direction is a type of acceleration. Even if your speedometer says a constant 10 miles per hour while you go around a turn, you are still accelerating. Even though the speed doesn't change, your velocity is actually changing, because your velocity to start might be 10 miles per hour north. So maybe your car is heading north to start. But after a little while, your velocity changes to 10 miles per hour east. Because the direction changes, the velocity is also different. And therefore, because the velocity is different or changes, you are accelerating. The symbol for acceleration is the letter A. And so we have our equation that the acceleration is the change in velocity. The change means to subtract. So we're going to have two velocities in these problems. And we're going to subtract them. The one at the end is called the final. The one in the beginning is called the initial. Now what I would recommend is in the box where it says the equation, write the circle here to the side. That's going to be more helpful than writing out the actual formula here. The next part in your notes here is it says units. The unit for acceleration is a meter per second per second. Also called, because the second's written twice, a meter per second squared. Either one is a relevant unit for acceleration. Now the very last box, I'm going to skip the one where it says examples for now, but the very last box, the gravitational acceleration, is going to become very important later on in the next section. And the gravitational acceleration is always the same number, negative, because it's moving down, negative 9.8 meters per second squared. So that negative shows a direction of a downward acceleration, which means that acceleration is a vector. The acceleration is a vector because it has a direction. Now some examples of acceleration in the very last box. Some things that might be accelerating as you are on them, because they might be speeding up, slowing down, or changing direction. Some examples would be like a roller coaster. Another example would be like a car. Another example would be like an airplane. Or even an example of a football as it is thrown through the air. The football's direction changes. Sometimes it's moving up, sometimes it's moving down. And it also speeds up and slows down as it's moving through the air. Now, if you don't have all the notes written down at this point, pause the video, finish writing the notes. Meanwhile, we are going to go over 3 questions, 3 types of problems involving acceleration. So once you're done taking the notes, unpause the video and continue on. On the back of your notes, we have this first problem that says, Mrs. Hopwood decides to take public transportation to the mall. As the bus pulls away, it speeds up from 0 to a speed of 15 meters per second in a time of 3.5 seconds. What is the acceleration of the bus? So in our menu, we're going to write down the values that we know. And I see 3 different numbers. The first number is 0. It says speeds up from 0 meters per second. Now, out of these letters, V stands for velocity, T stands for time, and A stands for acceleration. You might think, well, none of those are speed. But remember, speed and velocity are the same thing. The only difference is velocity has a direction. So our speed and our velocity are the same thing. So speeds up from 0, and that is the first or initial velocity. So the first one you see is always the initial. Then it says to a speed of 15 meters per second. So that is another V, and that's the final or second velocity. And then we have the 3.5 seconds. And again, we look for the words before it to figure out what it represents. It says a time of 3.5 seconds. So out of the 2 remaining letters, T is going to be time. 3.5 seconds. We want to find the letter A. So now we're going to go back to our equation here, which is right here. Okay? And we're going to figure out what is the equation for the acceleration. So we need to have an equation for A, and so we're going to look at what we do with VF, VI, and T. And I see that I'm going to subtract VF and VI and then divide by the time. So in this working equation, make sure you're just writing letters down, no numbers yet. Now watch out, make sure you write the correct number in the correct order. VF is 15 minus VI, VI is 0. And then we're going to divide by, we have the time, which is 3.5. Now make sure when you do this problem, it's good to write the next step, to actually subtract the 15 and the 0 and press equals before you divide. So now 15 minus 0 is 15, and we're going to divide by 3.5. We do so and get our acceleration, and it is 4.29. Again, that is simply the number. We also need the units. Looking back to our units, They are meters per second squared. Looking at the next problem. A bus comes to a sudden stop to avoid hitting a dog. It slows down from a speed of 15 to a speed of 0 meters per second in a time of 2.3 seconds. What is the acceleration of the bus? What I'd like you to do is take a moment, pause the video, and write down your menu, write down your givens. Once you're ready, unpause the video. Okay, the first number, 15, says a speed up. So this is our v, and it is our first v given, so it is the initial. We also see a 0, and it says speed of 0. That is our second speed given, so that is our vf. Finally, I see 2.3 seconds. It says a time of 2.3. That is my t. We want to solve for the letter A. So again, we need our formula. And we want to solve for that letter A. So what do we do with VF, VI, and T? At this point, pause the video and write down your working equation. And when you're ready, unpause and see how you did. We see that our formula with VF, VI, and T should be VF minus VI divided by T. Next, we're going to put in the numbers for our formula. So at this time, pause the video, write down your numbers, and when you're ready, unpause the video. You want to be careful in this one because VF, in this case, is 0. So we're going to start with 0 minus VI is our 15, and then our T is 2.3. As I said before, make sure you solve for the subtraction first. 0 minus 15 is a negative 15. And then we divide by 2.3. When you divide by that, you actually get a negative number. Negative 6.52 meters per second squared. Now the reason it's negative is because we are slowing down. So when you slow down, you should get a negative number. The very last problem says Mrs. Hopwood is walking at a speed of 2.7 meters per second. She then comes to a stop to look at a new pair of shoes. If she accelerates at negative 0.75 meters squared, how long does it take her to come to a stop? What I'd like you to do is pause the video, and then at this point, once you're ready, try the problem. And once you're ready, unpause and see how you did. Okay, in this problem here, we see the 2.7, and that represents the speed to start. Then we see the complete stop. Whenever you see the word stop, that means one of the speeds is 0. Finally, we see this negative 0.75, and it says she accelerates. That's actually our A. We need to solve for T. So looking at our equation, the equation with VF, VI, and A looks familiar, VF minus VI, but now it's divided by A. Our VF is 0, our VI is 2.7, and our A is negative 0.75. Remember to do that first step of subtraction. We have negative 2.7 divided by negative 0.75. And we get a time of 3.6. But we do need units. The units in this case is seconds for time.